almost. Hey guys, here with Joe, the tech from Lennox, and Mike, both great guys. We have been able to determine that the connections to the gas valve possibly are faulty within the valve itself. It does have a board, as we were just talking about. Some of these newer valves, they call them smart valves. I call them dumbass valves. But
yes, this 24 volt gas valve has two connections, common and power to come to it to energize it, and one of them is loose. I suspect it is the top one. So right now the furnace is running, the burner is in operation, gas valve is energized. Now if I'm going to wiggle this connection here,
it pops right off.
all right, and that shouldn't be a problem. I should be able to wiggle that all day long.
Right.
And the issue is, and now we see this voltage here, even though the gas valve is not being energized from the control board, our voltage is showing it like 14.45 volts. This is like a phantom voltage you see when there's no good connection between the control board's two wires, the common and the terminal that energizes the gas valve. You're not in connection with the coil that's in this gas valve. So the resistance of that coil is not in the loop with these connections. So we see this high number. And now we've got 24 volts, igniter is energized, and we got no pulse from the gas valve because I was not holding it down in order to enable the connection. We have a defective gas valve.
Right. So Joe, just to go through what I went through here with it running and running and running, do you think over time, because of the voltage or that disconnection, maybe it heated it up? And
it's a situation where it's a likely defect from the beginning, intermittent connection, and it can be very temperature sensitive.
Right.
So depending upon what the environmental conditions are in the burner compartment itself, it could make it that erratic.
Right.
Anything could drive you crazy. We were very fortunate that we were able to catch it in the failed state today. And the important part is when you're doing this kind of thing, you come up on a job that you got a known history on, sneak up on it like a Yakuza. Touch as little as possible.
Right.
Carefully take the door off like a bomb disposal technician. And then have your tools ready and set up depending upon what you think you might be chasing.
Right.
We were looking for flame
rectification.
So we set up on that before we went, and then we immediately had to go to a meter because we had this phantom condition where we were not getting the gas valve to open. We weren't even hearing the clunk of the gas valve.
Right.
So that's where we needed to start looking for the voltage coming up from the control board at the appropriate interval, and then also being able to check the microamp current even when we did get it to go,
right,
to see if we did receive that current. We had a good current here. We had 3 microamps. I think it's 1.5 it needs to be or higher on this.
I thought,
I
can't
in order
remember.
to keep it to go.
I thought it was 2.5 or something.
The point of this situation is we have a failed gas valve here, a defective gas valve, and it's something internal to the connections at the top. You can literally wiggle it and make the connection and unmake the connection.
So, but this isn't really considered a smart valve, though, right?
No, this is just a 24-volt gas valve.
So
there's a small little PC board. There's nothing else on it other than
those
terminals.
got 24 volts.
There might be a resistor or two for the electronic circuit in here for them to damper that connection. But there's no hardcore electronics, but they just make that connection. They do it with that little PC board, and there's a problem with the connection. So
gotcha.
I'm going to warranty the valve and get this customer back to the show.
All right, man. Hey, Joe. You the man. This is my new best friend here, Joe. No, man, but I was going crazy. I ain't gonna lie. I was getting ready to like rip this furnace out, buy one out of my own money, go just put it back in. I was getting pissed. But it was luckily that every time I came here, I couldn't get it to fail. And then as soon as I'd leave, well, it would last 3 or 4 days. And then the last time it lasted for 7 days. And then it failed on Thanksgiving of all days, which that's typically how it works.
What can happen of the breach, since the connections, the wiring that
it knows the holidays,
the valve it's in, the solenoid itself, the wiring in the solenoid is very, very small gauge wire.
Right.
Very thin.
Right.
And they only use that to come up to make the connection to this little PC board
Gotcha.
for the terminals.
Right.
But it's a very fragile connection. If it's made correctly, it'll last while it's in this plastic cover, and if nobody really jerks on it really hard.
Right.
But there's a issue where there was a gap. There's no tension on whatever's connecting in there at all. It's just laying there.
Now,
As you have an intermittent connection problem, the more times it happens, if it's loose enough, it can arc a little bit, and then it can make the gap bigger. It can start burning up the wire or the terminal,
or the board,
increasing the gap. And now it's going to be less and less reliable than it was, even when it first presented the symptom. So you had a degrading failure. In all likelihood.
So, is that one of the reasons that you asked me? Well, I understood about the burners, right? When you asked me about propane. But also, in doing that, you have to remove these wires and put springs and stuff like that in there.
Oh, yeah.
Right.
If you're going to redo this valve and convert it for propane conversion, you would have disturbed it. So if it was a suspect valve to begin with, in all likelihood, you would have hurt its life expectancy from that point.
Absolutely. All right, guys, you heard it from the horse's mouth. We're going to get her a valve and keep it moving. Anyway, man, you guys be good today. Big Red.